The next part in this chapter is called cascaded operation amplifier, where we have multiple stages of operation amplifier. So we don't have only one, but we have, for example, 2 or 3 or more. Like, for example, this one here, this circuit. So in this circuit, what we need to do is to solve first, of course, is this one, so that we can get VA, and then after that we solve this one to get VO, which is output. If we look at the first one here, we can notice that this is inverting amplifier. So in this case, VA equal negative this resistor over this resistor multiplied by this voltage. And then after that, if you look at the second one here, this look like summing amplifier. So in this case, VO equal negative this resistor over this one here multiplied by this, and this one plus this one, or minus this one over this one time this voltage, and so on. This is how we do it. So try to do it step by step. For example, if we look at this circuit here, so we start with this one. We start with this part here, this one here. Okay, so this is the circuit. Let's make it again. Here's the entire circuit. Okay, so we start with this circuit here, with this operation amplifier. And then after that, we'll solve the other one. Then next, we'll solve don't solve this one first, because we have to solve this one here, because it is in the input. So we'll solve this one, then this one, then we'll go to this one, and at the end, we solve this operation amplifier circuit. If we look at this circuit here, first one. Okay, so for the first one, as we know, then the two inputs are the same, the two currents are 0. Then if this voltage here is 0.4 volt. We know that this one is 0.4 volt because we have a source. So these two are the same, and it is 0.4 volt. And this point is connected to this point, to the output. Then the output also is 0.4 volt. So now we're done with the first one. Very simple. Second one, which is this stage here. Come on. Okay, this one here. Okay, this is the second one. And if you notice, this one is inverting amplifier. If you do not notice that, that's fine. You can just solve it as regular. So you just say that the input currents are 0, and the two input voltages are the same, and then you apply nodal analysis as the input. But if you notice that it is inverting amplifiers, in this case, the output here, which is called V1, okay, equal negative 80K divided by 20K. I don't need to write K because they will cancel each other, multiplied by the input, which is 0.4. 0.4, that's it. Okay. Then in this case, you can just multiply to do it like this: 80 divided by 20 times 0.4 equal 1.6, but it is negative, of course. Then this one here, the V1 in this case will be negative 1.6. Negative 1.6. Let's erase everything. Then now V1 is negative 1.6. I know this one is negative 1.6 volt. There's a point here. Volt. So we're done with this one. Before we solve this operation amplifier, we have to go back to this one here, because its output is the input of the stage. So this one is very similar to the one on the top. This 0.2 volt and this one is 0.2 volt. Okay, so these two are the same, 0.2 volt. And these 2 points are connected, or the output is connected to the input, then the output also is 0.2 volt. So here the output is 0.2 volt. And this is connected to this point here. So, okay, so now we have here 0.2 volt, 0.2 volt. So now we are ready to do the final stage. The final stage, if you notice, it is a summing amplifier. But if you don't notice that also, again, you can just solve it in the regular way. So that, okay, for example, this one is 0 volts, and this one is 0 volt, and then the current is 0, the input current is 0, and you apply node analysis at this black node here, this node at the input here. You apply it at this node. Let's see here again. This node. You apply it at this node. So in this case, this current plus this current plus this current equals 0. Or you can, if you notice that this is summing amplifier, then you can write the equation right away. Then you know that VO, here it is, let me write it here. VO equal negative, and between brackets, 80 divided by 40. Again, you don't care about the K because all resistors are K, so they will cancel each other. 80 divided by 40 time what? Time V1. V1 is negative 1.6. Okay, plus 80 also divided by the other resistor here, which is 20K. So this 80 divided by this 20 time what? Time the other input, which is 0.2. That's it. Then you can say equal whatever, you can calculate it and find the value of VO. So VO, we have a negative side outside, so don't worry about this negative. We know that it is negative at the end. 80 time 40 or divided by 40 time 1.6, and it is negative. Plus 80 divided by 20 time 0.7. 0.2, sorry, 0.2. And then you close it, or say equal. So the result is negative 2.4. The total is negative 2.4, and you have a negative side outside, then the result will be 2.4. 2.4. And this is what we have here. It is 2.4 volt. So this is how you do it. Just try to solve step by step, one stage by stage. So, for example, the second one here, we have this voltage is 0.4. I know this. Okay. And you do not have current here because this is the input current. The input current is 0. This one is 0 ampere. You don't have current here because this is the input of the operation amplifier. Since you don't have current, you don't have voltage. Then also this point is also 0.4. Both of them are the same. Why? Because you don't have voltage dropped on the 20K because the current is 0. Now this point is 0.4, then this is also 0.4, then this is also 0.4. So we're done with the first stage. Okay, so these 3 black nodes here, this one, they are all 0.4 volt. Now we can go to the next stage and see if this one is one of the stages that the circuits that we know. For example, is it inverting amplifier, non-inverting, and so on. This circuit is inverting amplifier. Why? Because this input is connected to the ground. Here it is. And the other one is connected to the input, which is 0.4 volt. Then you can simply say that this output, which is called here VL, this VL, because if the VL is the voltage across the 2K, so in this case, this is 0. We know that this one is 0, then this VL. So VL equal what? Equal negative, because this is inverting amplifier, 250. Again, you don't worry about K because all resistors are K, divided by 100, multiplied by 0.4. The input is 0.4. Then when you multiply it, it will be you can see that this is negative 1 volt. But let's see, 250 divided by 100 times 0.4 equal 1. And you have a negative side outside, then it is negative 1, as you have here. Okay. Then next slide is another example. Here also, let's see, we have two operation amplifiers. Then we'll start with this one first, with this one. Okay. Does this look like any known, for example, a circuit? Is it inverting or non-inverting amplifier? Okay. Maybe it doesn't look like any one of them, but actually it is a non-inverting amplifier. Why? Because the non-inverting amplifier is this circuit here. It looks like this. Let's see here. Delete all this first. Select all. Okay, let's do it. We know that the inverting amplifier, non-inverting amplifier, you have the source here, V input, and you have a resistor connected to the ground, and another one connected to the output. This is a non-inverting amplifier. Okay, but here we have a resistor in the middle here, and then we have this 3 volt. This one is 3 volt. Okay, and we have this 10K and 50K. 50K. Okay, so does this resistor make any difference? No, it doesn't make any difference. Why? Because the current here still 0 ampere. The current still 0 ampere. So if there is no current in the resistor look like a short circuit. It doesn't have any effect. Okay, so in this case you can simply say that this output here, the output is V1. We call it V1 here, it's not VO. Okay, so this one, let's call this V1. Equal what? Equal 1 plus the output, which is 50, over the input resistor, which is 10, divided by divided by 10, multiplied by the input, which is, what is the input? 3 volt, multiplied by 3. Of course, 50 divided by 10 is 5, plus 1 is 6. 6 times 3 is 18. This is what we have here. So V1 is 18 volt. V1 is 18 volt. This one is 18. Okay. And once you know V1 is 18. Of course, these two, look at the second stage. The second stage, these two resistors are the same. There's no difference. These 2 points are the same. So the voltage is the same in both of them. So if this one is 18, the other one is also 18. If this one is 18, this one is also 18. And this point is connected to the output, then this is also 18 volt. Then VL is 18. Then VL is 18. So let's erase this. Look at this one here. So the first one is a non-inverting amplifier. It is non-inverting amplifier. You see here, I just solve it in regular way. I did not solve it as it is non-inverting amplifier. So you can do that. You can just solve it. If you don't notice that this is non-inverting amplifier, it's okay. Just solve it in the regular way. But here we have the source is connected to this node, and the other one is connected to the ground through a resistor and connected to the output through another resistor. So this V1 is the output here for this one. Then if you want to calculate the output, this V1 equal what? V1 equal 1 plus 20 divided by 10. Okay, 1 plus multiplied by the input source, which is 1 volt. 1 volt. That's it. So in this case, 20 over 10 is 2, plus 1 is 3. So time 1 is 3. 3 volt. And this is what you have here, 3 volt. Okay, so this is the first stage. The second stage look like exactly very similar to this one. very similar to this one, but it is not a non-inverting amplifier. Why? Because non-inverting amplifier, this resistor here, the resistor must be connected to the ground. Must be connected to the ground. Here, the resistor, which is 30K, is connected to V1. It's not connected to the ground. Then in this case, this one, there is no way that you can do it here except by the regular method, which is you say this voltage equals this voltage. This one is 2, then this one is also 2. So that's why we have 2 volt here. And the two currents are 0. The two input currents are 0. Then you apply nodal analysis here. Then this current plus this current equal 0. The first current is 2 minus V1 divided by 30K. And the second current is 2 minus VO divided by 40K. Then you can solve this one is very easy because V1 is already 3. We know that V1 is 3 volt. You know that V1 is 3 volt. And then you can solve this equation in one unknown, which is VO. You can find that VO equal 0.67. How we do that? You can multiply by the common multiplier here. What's the common multiplier for 30 and 40? 120. You multiply everything by 120K, of course. 120K. Then 120K, when you multiply it by the first term, 120 divided by 30 is 4. Then 4 times this. What is this? 2 minus 3 is negative 1. This is negative 1. So the first part here is negative 1. When you multiply it by 4, will be negative 4. So it will be negative 4. Okay, so again, this is 120 divided by 30 will be 4. 4 multiplied by negative 1 will be negative 4. Plus 120 divided by 40, second one here, 40 will be 3. 3 multiplied by the numerator, 3 times 2 is 6, and minus 3 times VO equals 0. Then in this case, you can just add this 2, that will be 2. Okay, then you can say 2. And you move negative 3 VO to the other side. So equals 3 VO. Then you can find VO, of course. VO equal 2 divided by 3, which is 0.67. 0.67. Okay.